Hey guys, this is Mr. Grice for Algebra 1, Chapter 9.1, Notes. We are starting a new section today, and we're talking about classifying, adding, and subtracting polynomials. Our learning target today is to be able to classify polynomials by degree and number of terms, and to be able to add and subtract polynomials. Hope you're ready to write down some definitions. Polynomial. Polynomial is something you've seen many times, and we've called it that before, you just might not remember it. Now, a polynomial is an expression that contains numbers and variables that are being added or subtracted. Okay? Standard form of a polynomial is when the terms are written in order from the biggest exponent to the smallest exponent. Now, we might have never said that that's standard form, but if you notice, whenever we're writing something, that's always how it is. Even when we're doing our y equals mx plus b, everything's always in standard form, where the x comes first and then the constant. Okay? So, let's get some more definitions down. Now, if you need to, at any time, just write the definitions down, just pause the video, and you can get that done. Okay? So, the first thing we're talking about are the specific names according to the number of terms. Okay? Number of terms means the amount of items. Okay? So, if we look at the example, let's say 4x. Okay? That's a polynomial with one term. Okay? Because there's only one thing there. Now, for those of you who speak Spanish or I think Italian, some of these you might have heard. If you're in reading classes right now, you know your root words, the mono, the bi, and the tri. Okay, mono, 1, bi, 2, tri, 3. Okay, you should know that. Okay, so that should help you out. So monomial, one term. Now say, hey, what's an example of a binomial? Well, Mr. Grice, if you just add an x. Well, good idea, except 4x plus x, you can simplify that to 5x, and that's a monomial, okay? So that is not a good example. Now, an example would be 4x plus 3, because they're things that I cannot combine together, okay? We can even add another variable there, and you cannot combine those together, okay? Now, a trinomial is a polynomial with 3 terms. So let's keep with these numbers. 4x plus 3x plus 2. But you're like, hey, wait, we can add the 4x and the 3x. Let's change that 4x to 4x squared. And now can I combine any of those? No, because they're different terms. Okay? So, the number of terms relates to how many. Okay, that's 1 term, 2 terms, and 3 terms. Okay? If it's more than 3, we just call it a polynomial. All right. Now, let's talk about specific names according to the degree, or the highest exponent. Now, a constant is a term without a variable. Okay? So if we just have a number, no variable, that's a constant. Now, a term with a variable to the first power, we would have to add a variable, because if the variable doesn't have a number, it's always to the first power. Okay? Now, so that was linear. The next is quadratic. quadratic is raised to the second power. And a cubic is raised to the third power. It doesn't have to be 3. We can just make them all 2. Now, we've talked about, this is just something to know. We've talked and made, there's my little graph. I've talked about linear line. Linear, okay? That's when we graph a line. If it's one variable, it makes a line, okay? Now, later, I think it's the next chapter actually, we're going to be talking about quadratics. And quadratics make the shape of a U. And if you go on to advanced algebra, excuse me, but if you move on to go to advanced algebra, you will learn how to graph cubics. And the cubic graph can look kind of like that. Okay, so it's kind of cool. Every single graph that you work with has a different graph, or every single power has a different sort of graph. All right, now let's go ahead and do this. It says simplify each expression by combining like terms if possible. And remember that like terms have the same variable and exponent. And then classify. We're going to do that by its degree and by the number of terms. Okay? So, on this side right here, this will be our degree. And over here, we'll classify it by the terms. And you should be looking back up here to say what it is. Now, I need to look at whatever the highest exponent is. Okay? So my highest exponent is 2, which means that this is a quadratic. Okay? And now by looking at the number of terms, I have 3 terms, which means it's a trinomial. So it's a quadratic trinomial. Let's look at B. 4y minus 2y cubed plus 3y. So if I'm just looking at the term, or the degree, I'm sorry, the highest degree is 3, which means that it's cubic. But now when I go to look at the number of terms, I kind of see that the 4y and the 3y, can I combine those to where it would be 2y cubed plus 7y? Okay, so that would be a cubic binomial, okay, because we're simplifying it, okay? And that was a bad example because I should have simplified first, I'm sorry. So for C, let's simplify this. I see that I can combine those two, and when I combine those two, what happens? They actually cancel out, and we're left with 9 minus 3, which is negative 3. So I don't have an exponent or a variable, so that means that's a constant, and there's only one thing there, so it's a constant monomial. Okay? All right, for D, let's see. The first thing I would do would be bring down my 7y cubed because nothing else combines with that. I'm sorry. The 6y squared and the negative 9y squared gives us negative 3y squared. And then we're left with the negative 2. So my highest exponent is 3, which means that this is a cubic. And there are 1, 2, 3 terms, a cubic trinomial. Okay, why don't you guys try E, F, and G and see how you do. Go ahead and pause the video, please. answers. Okay, you can kind of see the things that I combined. Now, just remember in E, n plus n, that's 1n plus 1n is 2n. Okay, we're adding those up, and that's how I got 2. Okay? All right, let's go ahead and flip it over. So now we're talking about rules for adding and subtracting polynomials. You can only add and subtract the coefficient, okay? And that's what we're doing on the other side. The coefficient is the number in front of the variable, okay, of like terms. So just remember that the exponents don't change. We are not multiplying or dividing the terms. So in our example right here, I would find the like terms and combine them. Okay, well that gives us 15x squared. Okay, and now my other like terms right here, that would give us negative 6x. Okay, because all you're doing is you combine the coefficients. Now, if you're having trouble doing that, just type it directly into your calculator. Okay, that one would be 2 minus 8. Well, 2 minus 8 is negative 6. Okay, now 2, you can get rid of each pair of parentheses by using distribution. Now, what number would I be distributing in front of the 2x squared plus 7? Well, there's a positive 1, and I would distribute that. And when I distribute that, it actually stays the same. Okay, but on the back side right here, you're actually distributing a negative 1. And when you distribute a negative 1, things start to change. Okay, because it's negative 1 times positive 4x squared. Well, that's negative. Negative 1 times a positive 10x gives us a negative 10x. And negative 1 times negative 1 is positive 1. Okay, so after we would distribute, and then that's where we get to 3, where always write your answer in standard form. So we would combine the like terms. 2x squared minus 4x squared is negative 2x squared. Next, I would look to see if there's anything to combine with the 10, the negative 10x, which there isn't. So negative 10x. And now let's look for the 7. Okay, 7 and 1, that gives us a grand total of 8. And then that would be my final answer. Okay, so that's what we're going to practice over here. So if I were to distribute just a 1, well, it's a positive 1, so everything stays the same. And distributing a positive 1 here, sorry, for multiplying everything by positive 1, it all just stays the same. And now we look to try and find like terms. So 2x squared and x squared gives us 3x squared. Negative 5x plus 2x, negative 3x. And then positive 9 minus 5 is positive 4. Okay? Right. Same thing with number 2. If you're distributing a positive, everything just stays the same. And now let's look for like terms. Okay? Got the 3x squared and then 2x squared, which gives us 5x squared. Oh, that's the only x, so 4x Negative 11 plus 4, negative 7. All right, why don't you guys try 3 and 4 on your own? Go ahead and pause the video. Okay, and there we go. So just make sure to, well, nothing could combine with a 6x squared. Negative x plus 5 gives me positive 4. And then the 2 minus 8, 6. Okay? So you're just finding things that are the same, combining them, and then making sure they're going order. Now, down here, there's something different. There's that minus sign, okay? Now, the first portion, nothing changes here because I'm distributing a positive. But on the back, I distribute a negative 1. And that's, once again, that's where things change. Because I'm multiplying everything by a negative, all I'm doing is switching the signs, okay? And now I look for things that are the same, like the 2x squared minus x squared. Well, that's x squared because it's 2 minus 1 is 1. Negative 5x, negative 2x. And this is where, once again, on your calculators, if you don't know, well, it's negative 5 minus 2. You can plug it in. Even if you start doing the click, click, plus negative 2, you get the same thing, okay? So minus 7x plus 14, okay? The first one stays the same because we're not distributing anything, and then we're distributing a negative 1. So it's negative 5x plus 8. Okay? Find your like terms. Well, the 6x squared is all by itself. Negative 5, negative x and negative 5 gives us negative 6x. And then we get positive 10. Okay. Now, 11 through 14, you guys are all on your own. Go ahead and pause the video and see how you do on the last ones. All right, and there you go. So, if you have any questions on those, please come see Ms. Carranza or myself. Otherwise, that's it for Algebra 1, Chapter 9.1 Notes. Thanks for watching.